so in this video, we are going to solve log equations by writing the equivalent exponential equation. So log base 3 of x is 4. The equivalent exponential statement is 3 to the 4th is x. 3 to the 4th is x, and 3 to the 4th is 81. 3 times 3 times 3 times 3 is 81. So we have 81 equals x, and we are done. X is equal to 81. Okay. Another way you could approach this problem is you could remember what log base 3 does. Log base 3 is going to take in a perfect power of 3 and spit out the exponent. So log base 3 of 3 to the 4th would be 4. That's what log base 3 does. It takes in a power of 3 and it spits out the exponent. So what must be true? X has to be 3 to the 4th. Yeah? All right, let's do another one. Log base what of 32 is 5. If we write the equivalent exponential statement, x to the 5th power is 32. Right? And so now we have to think, what number times itself 5 times is 32? Well, 2 times itself 5 times is 32. Let's see that. 2 times 2 times 2 times 2 times 2 is 32. 2 to the 5th is 32. Right? So what does x need to be? X needs to be 2. Answer, x needs to be 2. Let's do another one. Log, when we don't write the base here, what's the base? It's base 10. Log base 10 of 100 is x. If I write the equivalent exponential statement, 10 to the x is 100. 10 to what power is 100? Well, 100 is a perfect power of 10. 100 is 10 times 10. It's 10 squared. All right, so I'm just going to rewrite that again with different color. 10 to what power is 10 squared? Oh, 10 to the power of 2 is 10 squared. Answer, 2. All right. So our answer is x must be 2. Done. Now, this one, you also might have noticed that answer sooner. Let's rewrite it. Log of 100 is x. Well, I know what log of 100 is. It is 2. Why? What does log base 10 do? It's going to take in a perfect power of 10 and spit out the exponent. Well, 100 is a perfect power of 10. 100 is 10 squared. What does log of any base do? It takes in a power of its base, and it spits out the exponent. Here the exponent is 2. 2 is x. Another way of looking at it. Let's do one more. All right, wait a second, I see 2 logs here. What's going on? Well, this one is simplifiable, right? ln of e squared. ln takes in perfect powers of its base. Its base is e. and it spits out the exponent. Maybe I'll do a little bit of scratch here. ln of e squared. Well, ln is log base e. Logs of any base take in powers of their base, and they spit out the exponent. ln of e squared is just equal to 2. All right, so this is just 2. So we have log base 6 of x is equal to 2. All right, and now writing the equivalent exponential statement, 6 squared is x. Oh, 36 is x, and we are done. Equivalently, instead of, because I try to not memorize a movement, right? Think about what log base 6 does. It takes in a power of 6 and it spits out the exponent. So here I'm taking in some power of 6, and what's the exponent? The exponent is 2. So I must be taking in 6 squared. X must be 6 squared. All right? Movements are okay to get some practice and to get some traction, but we need to work on a deeper understanding to commit some of these things to memory. Okay? So I hope this video was helpful. Thank you so much for watching.